Okay, so we are going to start from the first chapter, electrostatics. Okay, let us start with electrostatics. And electrostatics chapter has been divided into two parts. If you see NCERT, first part is electric charges, electric charge and field, electric charge and field. Okay, so let us start this chapter. And what are the important things in this chapter? There are some 14 to 15 topics and subtopics will be there in this chapter in NCERT, if you see that. Okay, so let's start with the first, which is the introduction part of this chapter. Introduction. First is introduction. Okay, introduction. So NCERT, if you read the introduction, it is very small, very brief introduction is there, but there are a lot of contents to think about that. So first thing that they are saying is that when we start, this electric charges, and we need to see first of all what are the phenomena that we are seeing in nature, because physics is totally based on the physical phenomena that is taking place in nature. So first thing is that what are the phenomena we see in nature which is related to this chapter. Okay, so we see lot of phenomena, so few phenomena or few things that have been mentioned, I will write that. Okay, so first thing is natural phenomena. Okay, natural phenomena related to related to static electricity. Static electricity. What are the natural phenomena which are related to static electricity? So some of the things which are given, and we will add also from our experience. We can add many other things. Okay, so first thing is that it is given that suppose if you take, for example, if you are rubbing two objects, if you rub, then they will get charge, right? And there are certain examples are given. First example is that you are taking off your cloths, particularly woolen cloths, or cloths which are made up of polyesters, right? Woolen cloths. So woolen cloths, when you are taking out from your body, they get charged, right? Because those cloths are moving against your body, so due to friction there is charging happens, right? And you will be getting some kind of crackling sound, and also some sparks, you will feel that. So first example is that this crackling crackling sound crackling sound crackling sound crackling sound and spark during taking taking off taking off cloths. So if a person is wearing particular what type of cloths, woolen cloths, woolen or polyesters, they have given example of saris also, such cloths made up, saris are made up of polyester. So what happens is that when such cloths are rubbing against our body, there is a friction happening, and because of friction charging happens, right? So due to that, now the question is, okay, charging happens, but how is this sound produced and spark produced? Okay, that is a phenomena. We'll try to understand what is happening inside that phenomena, what are the physics used there. Okay, this is one phenomena that happens. Second is there is shock. They are talking about a mild shock, not very big electric shock, but we feel some mild electric shock when you are, let us say, you are walking, or you are sliding over the ground, and you touch some metal bar or metal rod. And another example is that electric shock you will also feel when you are when you are sitting in a bus or a car, and you're opening the doors, or you're sliding, after you're sliding over the seat, and then you are touching some metal bar. So the second thing you can say that electric shock, electric electric shock, electric shock, when touching or holding, touching or holding touching or holding iron iron rod or iron bar of bus, after sliding, sliding from after sliding from seats, after sliding from seat, or or during opening of opening of during opening of car car's door, after sliding from seats. Okay, so suppose a person is sitting in a car, and he just slides or gets up from his seat. While getting up, he definitely slides over the seat. So whenever a person slides over the seat, what happens? Electrification happens, so charges are developed due to friction. And when he holds or he opens the door of the car, which is metallic body, so charge transfer take place from our body to that door, and it goes to ground. So there is a current passes through our body, but that is not too much, otherwise it may means make us injured, right? So the current is very small, so that due to that current, this is electric shock. Okay, so these two are important things are given, and another example which is given is a lightning, lightning, lightning. Okay, so these three important things are given in the introduction itself, but we need to probe further into these things, what is happening. Now these are phenomena which are related with static electricity, and what is happening in that we need to understand what is the physics behind that. Okay, and how this chapter, after going through this chapter, you will be able to explain those things more deeply. So right now, let us briefly discuss about what is happening in these three processes. Okay, let us discuss that. So first thing, you need to understand first what is the definition of static electricity. So let us go step by step asking questions. Okay, and then things will become more clear. So first thing is that what is static electricity? What is static electricity? This is the first question. So static electricity means it is the accumulation of charges on the surface of two bodies, right? Suppose two bodies somehow they get some charges, that phenomena, that is what is static electricity. And note that the charges should not be moving, charges should not be moving. That is why the term is static. Static means charges are not moving. So here we can define this as the accumulation, the accumulation accumulation of charges on the surface of bodies when the charges are not moving, when the charges are not moving. That is what is static electricity. So static electricity does not involve the flow of charges. That may happen after, or that may happen due to static electricity. Charges may flow, but static electricity involves what accumulation of charges. And how charges can accumulate? due to friction. One example we are seeing that whenever you are rubbing two bodies, charges are produced on both the bodies. How charges are produced? Because the atoms have nucleus which is inside, and the electrons are there, and the outermost electrons are loosely bound. So when you are rubbing two bodies, their atoms rub against each other, and the electrons may get knocked out from one of the body, and it may go into the other body. So definitely those that body which is having more electron affinity, it will capture the electrons. The body which is having less electron affinity, or the electrons are loosely held, that it will lose electron and it will go to the other body. So this is how electron transfer will happen, and due to this electron transfer, there will be charge developed, or accumulation of charges will happen, right? So that is what is happening, accumulation of charges happening in all the three phenomena which we are seeing. Charges are accumulating, but how can we explain the sound which is produced, and the electric discharge, or that sparks that is happening? So two things are happening. One is um, electric discharge. So what is electric discharge also you need to note here. Related to the same question, it is that okay, charges are developed. So these charges which are developed, this is by friction. So you can note that this accumulation of charges that is happening, that is called charging or electrification, or electrification, charging or electrification by friction. There are other methods also to charge a body, but this is one of the common method that we can see day to day, charging or electrification by friction. So this thing will happen. So in static electricity, once charges are produced over the body, that is electrification is over. Then next, electric discharge or sparks will be produced. How spark will be produced? For that we need to understand that the second thing, that what is electric discharge, how sparks are produced. So due to potential difference due to potential difference potential difference between two charged bodies between two charged bodies due to potential difference between two charged bodies, sudden flow of charges sudden flow of charges take place. This is called electric discharge. This is what is called electric discharge. So these two important means this phenomena what we are seeing can be explained by these two important concepts. One is charging is happening due to friction, because bodies are rubbing against each other, and once this body get charged, then there is some flow of charges happening because of potential difference. Even though if there is no suppose if the bodies are touching each other, then definitely charges will flow. But suppose bodies are not touching each other, then also charges can flow. So we'll understand that. So let us take the first one, this crackling sound and spark produced. So when a person is taking off cloth, due to friction, charges are developed between the human skin and the cloth, right? So cloth and human skin, they are touching each other and they are rubbing each other. So because of that, charges are developed. Now because these two bodies are having charges and they are also touching, while you are taking off the cloth, they are touching with the human body also. So whenever they are touching, wherever all those points wherever touching is happening, there is charges are produced, means charges are flowing there. And as the charges are flowing, there is electric discharge happening, and due to the flow of charges, there is exchange of energy also. So that energy is coming in the form of sound, crackling sound. So that spark is nothing but, you can say, it is some form of energy, right? So that's how crackling sound is produced. Similarly, the same thing happens now. Now talking about electric shock, because the charges are flowing, through our body we are getting that electric shock, but it is not very big amount of electric shock, very mild shock happens. Okay, so this is how we can explain that. And why only touching the iron bar? Because iron bar is a conductor. Your body has become charged because of rubbing through the seat on which we are sitting. Now you got up the seat, so your body got charged, and when we hold the iron bar of the bus, or hold the door, so that charge transfer takes place from our body to that door, and ultimately it will go to the ground. Okay, so through the conductors the current is passing and we are feeling that shock. Are you clear about this? Yes. Now the third case, lightning. Lightning, little bit we should try to understand, because lightning is such a common phenomena, right? A storm happens, lightning happens, thundering also happen. Thundering also is like sound is produced. So we'll also try to understand lightning and thundering, how they are happening. Okay, so lightning, let us understand lightning. Here itself little bit we can try to understand lightning. So in lightning, what happens is, let us say that this is cloud, and this is, so many clouds can be there, and this is ground. Let us say this is ground. So what happens is that this cloud is nothing but there will be water drop will be there, and also ice will be there, ice. Here also water drop, and some ice will be there. Okay, so what happens that these water molecules are moving against the ice inside the cloud. Here also, any cloud you take, this is happening, and because of the friction they are developing charges, right? They are developing charges, and not only small charge, very large amount of charges or very large amount of potential difference can be developed, and ground or earth is also having some potential. Okay, so what happens is that there is potential difference establishes between these two clouds. Okay, let us consider that there is some potential difference is established. Similarly, potential difference can establish between here, and potential difference can establish between that. So potential difference can exist between two clouds, between the clouds and the ground, right? And due to very high potential difference, now air is there in between, right? We have air in between. Let us consider that here lot of air molecules will be there. And air is a good conductor or bad conductor? What do you think? Is air good conductor or bad conductor? Bad conductor, right? So because air is bad conductor, current cannot flow between these charged bodies, but because of very high potential difference which goes into 10 to the power 6, even million volt potential difference happen, and because of million volt potential difference, the air between these charged bodies, air become ionized, or that is called dielectric breakdown of the air. So air which is made up of the gases, it become ionized because of very high or very strong potential difference or very strong electric field. And then after the air become ions, then it will become like a conductor, and then there will be uh, charges flow. So charges can then flow between the this cloud and this cloud, and charges also can flow between the cloud and the ground. Okay, that is the reason why we are seeing that. So here there is an important thing, that dielectric breakdown happens, that we can note. Dielectric breakdown of air. Dielectric note, dielectric breakdown of air, which is an insulator. Dielectric breakdown of air happens due to very high potential difference between clouds or between clouds and ground. Okay, so this dielectric breakdown means the air which is there in the form of molecules, it will become ions, and once it becomes ions, then it will become like a conductor, right? Then it becomes a conductor, and then it will allow the flow of charges, sudden flow of charges. That is what is electric discharge is happening. Then question is, how sound is produced? Sound is produced because wherever this discharge happens, this path can be some random path. So there is a path, this is a path, this is a path, this is a path. So along this path, what is happening? Discharge is happening. So there it is forming like a conductor or layer of ions will be formed. So the air gets so much heated up, very much it gets heated up because of so much heat produced, and lot of heat is produced, and because of that heat, what happens is that that heat energy converts into sound energy, right? Actually, how that sound happens, you can think about the concept of sound waves. So as the air gets heated up, suddenly it gets heated up, there is a high temperature, and because of high temperature, lot of expansion of the gases will happen, and that expansion of the gases will create a wave there, sound wave. That sound wave travels, that we hear as thunder, right? That is the main reason behind this. Are you clear about this? Okay, so this is the introduction part here. Okay, now let us one more point we are going to summarize in this introduction part is what this electrostatics chapter will deal with. Electrostatics. So electrostatics deal with deal with phenomena, deal with charges, deal with electric charges, electric charges and phenomena related to electric charges at rest. Remember, the term rest is important. That means charges should be at rest. Charges should be at rest. Electric charges that we are studying, the charges are rest. And what are the phenomena that can happen? Now let us try to understand some of the phenomena. So first phenomena that we can say that if let us say two charges are at rest, two charges are at rest. Let us say these two charges are at rest. It can be any two charged bodies. So charges at rest produces forces between them. We can see that two charged bodies can attract or repel. If they are similar charges, then they will repel. Opposite charges they attract. So that means there is force between charges. Force, which is called electrostatic force. Electrostatic force between charges at rest. Okay, this is one thing. Then another thing is that the charges which are at rest can also produce electric field. Suppose that there is a charge and this charge is at rest. So at any point, let us say r distance from it, any point, it will produce an electric field or it will show electric effect. What is electric field or electric effect? That if you bring any other charge particle at that point, it will experience force. Why? Because it is coming in the environment created due to this charge, right? So whenever there is a charge, it creates some environment around it. That environment or that space is called field, or that region is called field. And if you bring any other charge in that field, it will experience force or it will experience electrical effects. So that's what happens. So it creates field. So charges at rest, electric charges at rest will create field here. So charge at rest, charge at rest creates electric field. Electric field. Not only electric field, it can also create electric potential. Electric potential, right? And there can be electrostatic potential energy between charges. Also, we can note that if we have more charges, not only one charge, let us say if we have many charges or a system of charges, let us consider system of charges at rest, all the charges at rest. So due to these charges which are at rest and due to the interaction of that charges, there is some energy stored. That energy is called electrostatic potential energy. Okay, so interaction of charges lead to electrostatic potential energy. Okay, clear. So these are phenomena. Now here there is a very important thing to note, that why only electric charges produce electric field? Why not um, does charge, if it, suppose if a charge is moving, will it also produce electric field? uh, will it also produce or not, or is there anything else will happen? So let us try to understand that point little bit more detail. So there can be three cases. There can be three cases. Charges at rest, charges at rest, charges charges at uniform motion. Uniform motion means constant velocity. Velocity is constant. And charges at acceleration. Okay, so there can be three conditions possible. Okay, three conditions can be possible. What are those three conditions? Charges can be at rest. Charges can be charges rest means this charge, let us say some charge is there. Q is the symbol used to denote charge. Okay, so this charge is at rest. So it will create electric field. Only electric field it will create. Okay, it creates only electric field. It creates only electric field and produces electric effect electric effect. So because it only produces electric field, it will show electric effect. Electric effect means if you bring any charge, it will experience force due to that field. Okay, and then what happens if charge is moving but with a constant velocity? So suppose that there is a charge, this is a charge but which is moving with a constant velocity. Velocity is constant. Then it will produce electric field as well as magnetic field. You should know that it is going to produce electric field as well as magnetic field. Why? Because moving charges behave like a magnet, right? Because the current carrying wire is like having moving charges, electrons are moving, and it produces magnetic field also. So moving charges with constant, right, it produces both electric and magnetic field, and therefore shows both electric and magnetic effect. magnetic effect and electric effect. What about the third case? Third case, when a charged particle is moving but the velocity is not constant. That means velocity changing, velocity is not constant. Here velocity is constant. So constant velocity means it doesn't have any acceleration, but here it has acceleration because velocity is changing. So if velocity is changing, there will be acceleration. Now acceleration may be constant or acceleration may not be constant. That is different thing, but it has got acceleration. What happens in this case? In this case also, it produces electric field, electric field, it produces magnetic field, magnetic field. So their effects will be there. Their effects will, effects means electric effect, magnetic effect. But there is an important thing, extra thing is happening here is, what is that extra thing? That extra thing is that it also produces electromagnetic waves. Electromagnetic waves. And waves you have studied recently. So electromagnetic wave is also a type of wave. So such particles which are, charged particles and which are under acceleration, it will produce electromagnetic wave and it will lose energy because it cannot keep on creating energy, right? Of course, if somebody is vibrating, like let us say some charges are under oscillation and from somebody is oscillating, right? So that oscillation of charges will produce electromagnetic wave. And suppose if you do not uh, allow any external source, then it will stop after some time because it will produce, or it will convert that energy of the oscillation, which is kinetic energy or potential energy, into electromagnetic waves. After that it will stop, and that was the most important Maxwell's theory, which Maxwell has given, which was challenging the Niels Bohr's model of atom, right? Or Rutherford atom was, you might have studied in chemistry that in Rutherford gave the planetary model that electrons are going around the nucleus. Yes, you have studied that in lower grades also, right? Yeah, so these electrons are going, but now Maxwell challenged that theory that if electrons are going, it cannot keep on going because it is under acceleration, because circular motion it is happening, and in circular motion there is a centripetal acceleration. If you take, it is going with a uniform circular motion. So because of that uniform circular motion, there is a centripetal acceleration, that charged particle is under acceleration, it will emit electromagnetic waves and it will lose energy and it will finally collapse in the nucleus. That was a major challenge which Rutherford model faced. To overcome that, the Niels Bohr model, he just overcome that, demerits by giving a different concept of physics. He gave the quantum concept he applied in the model of atom, and he just overcame. But basically, it was not overcome because Maxwell theory posed a challenge for that. He had to use a different physics altogether because that mechanics we cannot apply there. So he used quantum physics to make his model, and for that only he got Nobel Prize, right? So that was the important thing. So this was all basic introduction part till now. Now we will start electric charges. Next is electric charges. Electric charges. So this is the second topic of this chapter. Topic by topic, we must remember everything, and particularly for you need, you need to completely, thoroughly, almost mug up all the points of NCERT. Everything should be in your fingers, right? So you should revise in that manner. Okay. So second topic is electric charges. Now, what is electric charge and what are the phenomena related with electric charges? Already we discussed those phenomena, which is static electricity. Okay, but now let us understand how electric charges was discovered, and some of the experiments which is also mentioned in NCERT. So let us first do few experiments. Let us take this experiment number 1. In this experiment, what happens? So two things were rubbed to develop charges, right? So what are those two things? So one thing is this glass rod. This is a glass rod, and silk cloth, silk, silk or woolen cloth. So a silk or woolen cloth is taken and it is rubbed over a glass rod, rubbed against each other. Then it was found that some kind of charges are developed. Of course, the type of charges they later fixed it by convention, which we know right now. So they said that the glass will develop a kind of charge that they have noted as positive charge. Glass rod develops positive and silk develops negative. Okay, they develop negative charge. Similarly, there was another set of experiment in which they repeated different types of material. One material was taken as plastic rod, another take they have taken plastic rod, and again, uh, but not silk. This time they have taken cat's fur, cat's hair. Okay, which is like very soft like cloth. So they did again, they rubbed against each other and they developed charges. So here this time it was found that it is developing another kind of charge, negative, and here this is developing positive charges, like that. Okay, then third you can add by yourself. This third is not given in that NCERT, but you can add this. So extra addition I am doing. In the third, which you can do is, instead of plastic rod, you can take a rubber rod. Rubber. This is a rubber rod, and you can take silk cloth. Silk cloth, because in many textbooks this is also mentioned, so we should know that. So silk cloth you take. Now here also after rubbing it develops negative charges and silk cloth develops positive charges, like this. So this was, how did they know that the charges are developed? So they did not first see charges, they see forces, because after rubbing glass rod with silk cloth or woolen cloth, they start attracting each other. Okay, similarly plastic rod, when they rub with cat's fur, they again attract each other. So they thought that there are some different kind of charges are there which are showing, attraction. And this glass rod after rubbing with silk cloth and this plastic rod after rubbing silk cloth, they also will attract each other because they have opposite charges. Another thing also to note that this glass rod, suppose you take two glass rod and separately rub them with silk cloth, so then those two glass rod will repel each other because they will get positive charges. So they observed, all this kind of, things. They observed that they, and silk cloth also rubbing, two times you rub, two separately, they also repel because they have negative charges. So they got certain observations that there is some kind of attraction forces are developed and some kind of repulsion forces are developed. So they decided to label the forces into two kinds. So one they have labeled as positive, another they have labeled as negative. That is purely by convention, and nobody can say that it is only positive. That is a convention. For example, the charge of electron is negative, all of us know, but it is fixed, fixed as convention, that has been taken as convention. Okay, right. So these things have been observed, and then they also did some other experiments. Some other experiment means they have taken pith balls to study the forces more. What are pith balls? Okay, pith balls. So this glass rod glass rod rubbed with rubbed with silk rubbed with silk or woolen cloth. Okay, so it has positive charges, and now you are touching a spherical ball which is called pith ball, pith, pith ball. So what is pith ball? It is nothing but like a conductor only, and it is very very light, very light. Anybody can hold it. Okay. So what happens when this pith ball is brought in contact with this charge rod? So it was found that the this also become a charge. This also become charge. Okay, it also develop charges. Why develop charges? Because charge flows from this body to that body. The positive charges flow from this body to that body, and they develop positive charges, and then when you separate them, they are showing repulsion. They are showing repulsion. So this method is called charging by conduction. This is called charging by conduction. Charging by conduction. So what happens in charging by conduction? You take a charged body, right, and bring a conductor and touch with that. So what will happen? Charge flow will happen, and after that both bodies will get similar charges, and if you separate them, they will repel each other, right? This is called charging by conduction. Clear? Are you clear about this? Okay, so they did so many things like that, and they, did they try to create, different charges on the pith ball. Another example you can take that this plastic rod rubbed with cat's fur, and here also another pith ball is brought. So we know that this develops negative charges. So it will transfer negative charges here. So that negative charges get transferred from this rod to this. This is also another pith ball. So like that, you can try to develop some charges on the pith ball and try to uh, hang them and see whether they are attracting or repelling. So this experiment they have done. First of all, they made the charge rods, either plastic rod or glass rod. After they get charged, they transfer the charge to the this pith ball. After that, they are doing experiment with the pith ball. How they are doing that experiment? There are some experiments like, this. They are keeping uh, like two pith balls like that. So they, if these are charged bodies, suppose they are similar charges. So similar charges means they will repel. They will repel. Similar charges means they are going to repel. Like that it will happen. If they are opposite charges means they will attract. And note that this is silk thread. Silk thread. Using silk thread, they are hanging this. Let us say here this is positive, this is positive. So they will be repelling, and this is positive, this is negative. They will be attracting. Okay, even negative also you can, so they may repel, right? So how did we get charges on the pith ball? We got charges transferred by conduction using those rods which were rammed by those cloths. Are you clear about this? Okay, so then they studied like how much, they are coming closer or how much they are getting farther. If they are getting more farther away, that means there is a lot of charges out there. If they are getting closer, that means less charges, means lesser deviation is happening, means less charges. So but they can understand that repulsion and attraction are there. So based on this, they decided that there are two types of charges. Okay, so they made all this convention. Then, okay, now so this was charging by conduction, right? and they develop forces. Then another method of charging is charging by induction. By induction also they can charge. In an NCERT there are two things they have explained: charging by induction, charging by induction, charging by induction. So they say that first method is, let us take it as method 1, which they have explained in the theory. So let us take two pith balls or conductors, same size, everything same, and they are kept on insulating stand. This is nothing but insulating stand, right? Now what happens is that you bring a rod charged rod you bring. Let us say that I am bringing positively charged rod, and we are not touching it, okay, we are just bringing it very very close proximity, and note that these two are conductors, they are conductors. So what happens is that the conductors have lot of free electrons, so free electrons from the surface of the conductor will get attracted toward the positive charge. So these free electrons will accumulate this side, so they will develop negative. And from where these free electrons will come, it will try to come from opposite ends. Opposite end is not here, but opposite end is here, because these two bodies are in contact, so charges can flow through this contact point also. So opposite end is this, so here it is losing electrons. Losing electron means electrons are flowing from that side to this side, and because electron has here electron is less now, so this is like a positive charge it is developing, these atoms on the surface, and these atoms on the surface are developing extra electrons, so because of that negative charges are there, right? Okay, then what will happen? Yes, but see, note that still the total charge is 0, because whatever amount of positive and whatever amount of negative, total charge is 0, and still you have not touched it, it is brought in close, right, very very close to each. Then what happens? Then they are saying that you separate this, try to separate them, try to separate them. What will happen? Separate these two spheres, okay, separate this. I'll copy this one. Hmm. Okay, they are brought here. Now this part I will remove this. Now we are going to separate, and note that this we have to keep it here only, this we are keeping it here only, okay, nearby we are keeping it. Now we have to separate, means let us separate this. So okay, like that we have separated it. Now what happens is that now here also some charges may develop. Will it develop or not develop? No, because here in between there was no charge, so it was just separated like this, okay. So that means it has got negative charge, it has got positive charge. Now what is happening is that this rod is getting removed now. Remove this rod. If you remove this rod, what will happen? You are removing this rod. So that means now I will take these two bodies. Okay, now I have removed this rod, because see this negative charge now it will not remain this side, rather it will come this side. So these negative charges I am going to remove now. Similarly, this side positive charge also I will remove. So where has this negative charge is gone? This negative charge has come this side. These positive charges has come this side. This have been removed, not that. This is removed now. Are you understanding this? Okay. Then after this, what happens? Still they are close to each other. Now let us make them also separate. Let us separate them. So if you separate them means let us make them move further. Uh, Further I separate. Now when I separate them further, what happens? These charges are uniformly distributed. These charges get uniformly distributed. Similarly, I will separate that one also. This also have been separated. So here also this positive charge get uniformly distributed. Are you clear now? So this is how we are able to develop charges on both this sphere. But not very important thing that the rod which was there was brought closer to this left side sphere, right? Rod was initially brought closer to this sphere. So this, how it has induced charges, this charge which is doing, this is called induction, because rod was having positive charge and it has induced negative charge in that ball. But this ball has got charge because it was in contact with them. So that is because of conduction. This we should note. So first sphere and second sphere, if you take this first sphere and this is second sphere. So first sphere got charge induced from the rod due to induction, but second had got charge because of conduction. Because if you see the previous diagram, this diagram, that's how it is happening, right? So here to here charge flow has happened because this was conduction. This was conduction, and here charges have happened because of induction. Induction. Okay. So this is the method of induction. Now there is method 2 also which is given. We will see that method 2. Method 2. Second method. Second method. What happens in this? This metal sphere again kept on a insulating stand, and this rod was brought closer. Now because of this induction happens, so here negative charges are induced and this side positive charges are induced. Positive charges are induced. Now what happens here is that there is only one sphere. This sphere is not there. But we want only, because if you remove that rod, this charge is plus minus will again redistribute and there will be no charge left, right? That's what will happen, because this is a neutral body. The charges are equal and opposite, but one side has got negative, one side has got positive on the same object. So total charge is 0 on this body. But how to develop charge then? We want to develop charge. So for that case, you need to do earthing here. Earthing means this end is connected to ground. This end is connected to ground. This is called earthing. Earthing. What happens in earthing is that it is a conducting wire. So this excess charge will go to the ground. Or you can say electron from the ground will come and it will neutralize this. So let us say electron from the ground comes. Electrons from the ground, electrons are negative charges. These electrons will come and it will neutralize all this positive. So now right side has no charge left, right? No charge left. Left side has only negative charge because this rod is inducing negative charge there. Now this side is no charge because of electrons coming from earth, it neutralize that. Then you remove this, remove the earthing wire now. Now you remove the earthing wire. Remove earthing. So in the next step, when you remove earthing, what will happen? What will happen? Let us draw this diagram. Second step. Now what will happen is that this charge negative will remain accumulated this side. Now that has been neutralized. Only charges in the left side. Now next step, what you do, you remove the rod also. Remove this rod. Remove. So once you remove this rod, what will happen finally now? Finally, on this sphere, charges will be equally distributed. So it has developed what charge? Negative charge. This negative charge will be equally distributed on this. Clear? Yes. So these are the three types of methods by which we can do charging. Charging by friction, charging by conduction, charging by induction. Three things. Okay. Now let us summarize this and let's note important property. So charging by friction, charging by conduction, charging by induction. Some important points let us note. So charging by friction will happen in insulators. Okay, this is the method. First let us write what type of method it is. It is a contact method. Contact method. Why contact? Because you need to bring the body together in touch. Okay, and charging by conduction, this is also a contact method. Contact method. Charging by induction is a non-contact method. Non-contact method. Okay, next. This method is suitable for insulators. For insulators. Because insulators, when you rub against each other, charges will remain localized in the body. Let us take two bodies and rub against each other. Charges will not distribute over the body, over the surface of the body, but it will remain localized. For example, let us take a balloon which is filled with air and rub with your hair. At that point, wherever you are touching with the head or with the hair, wherever contact surface is there only it will develop charge. Other place it will not develop charge. Otherwise, if suppose it is a conductor and develops charges everywhere on the body, and because you are touching it, what will happen? Through the hand or through our body, the charges will pass to the ground. Okay, so that is why we use insulator for charging by friction, and in this case, this is used for conductors, because in conductors only charges can flow, and this is also for conductors. Because for conductors only charges or free electrons will be accumulated. Then next here, what happens in this? What kind of charges are produced? So opposite charges are produced. Opposite charges are developed. So when you rub two bodies, electron transfer will take place. So if a body is losing electron, that will become positive charge. If a body is gaining electron, that will become negative charge. So opposite charges will happen. But in charging by conduction, similar charges will be developed. Similar charges will be developed. And what about in this case? Here opposite charges will be developed. Opposite charges will be developed. And now you can write what will happen because of these charges. So note here that opposite charges develop means what will happen? Attraction will happen. Attraction. Here similar charges develop means repulsion will happen. Repulsion. Here opposite charges develop means attraction will happen. Okay, so this is the point we should note, that if you do charging by friction, finally the objects will be attractive, and charging by conduction means finally they will repel each other. Charging by induction means they will attract each other. Okay, so these are the important points that we should know. Now, last point for today, let us take one last point, that suppose if you take a body, this body you want to test, body to be tested, for charges. Suppose if I give you a body and I say test and tell me what kind of charge it is, right? What kind of charge it is, you have to tell me what kind of charge it is. So what you will do, you will, and assume that this is like a, okay, it may be conductor, it may be insulator, you don't know, let it be. Whether it is conductor or insulator, that is not important, but this body you have to test. Let us bring a rod and let us bring a positive charge rod. You can bring a negative charge also, that means this is already you have, you are bringing a charge body to figure out what kind of charge is present in this body. So what will happen now? Because of this, definitely induction will happen, and note that if it is a insulator, induction will happen here in localized place, not so much induction will happen, very less, because even insulator have some amount of free electron. It's not that free electron is not at all there. Insulator means it will have very less amount of free electron, but conductor will have lot of free electrons, right? But less free electron will be there, so some induction will happen definitely. So here negative charges will be developed and some positive charge will develop this side. Okay, some positive charge will develop this side, and now you will see that um, due to this negative charge, now due to this negative charges, this positive charge, there will be an attraction force, there will be an attraction force, there will be attraction force, and due to this positive charges here and this positive charges, we are talking about charges on this body and this rod. So this rod will try to attract this surface, and this rod will try to repel that surface, rod will try to repel this, repulsion will happen. But here there is an important point to note, that this force that we are studying here, uh, this force, this force of attraction will be more as compared to repulsion. Why it is? Why it is? Because this charge is near to the rod, means this surface is near to the rod, so its influence will be more, and this charge is further away from the rod, so its influence will be less. Okay, so attraction is more and repulsion is less, attraction is more and repulsion is less. So because of this, what will happen? This body, or this body which you want to test, it will experience a resultant or net attraction, net attraction. Okay, now I have taken initially, let us say the body is, let us say body is a neutral body. This will happen is, that means a neutral body will still get attracted due to induction. What happen if this body is a charged body? Charged body means either it can be positive or negative. So suppose this body which you want to test is a positively charged body already. Already it is positive charge. Then this rod which you have brought as positive, then definitely repulsion will happen. Definitely this body will have repulsion. And suppose this body which you want to test is negative charge and rod is having positive charge, then definitely there will be attraction. Definitely there will be attraction. Now here it is an important thing to note that attraction is happening for two cases. One, if the body is actually having negative charge, and one if the body is having no charge, but it is getting attracted because of induction. So attraction is happening, you cannot sure whether the body is neutral body or charged body. Here in this case it is a neutral body. So neutral body is also getting attracted due to a charged body. But repulsion happening means definitely that is a charged body, right? Are you clear that? So if a body is getting repulsion due to other charged body, that means that body must also be charged of the same type of charges. So we can say that repulsion is a sure test. Repulsion is a sure test. Sure test of charged body. Sure test of charged body. Okay, so today we have covered up to this much. Then next class onward we will cover about the properties of charges, like how charges, what are the nature of charges, and what are the properties, conservation, quantization, and all that, right? So now what is your task is, homework is, you need to go through NCERT, read NCERT paragraph by paragraph, make proper notes in the class. You don't have to depend on anybody, you have to start doing your independent study and try to bring out some points, right, from the book, which the NTN, they can ask questions from that, fine. Okay, then let us meet in the next class. Okay, bye bye, thank you for attention.